exercise 5.1. Question number 3. Examine the following functions for continuity. First, fx is equal to x minus 5. Second, fx is equal to 1 upon x minus 5 when x is not equal to 5. Third, fx is equal to x square minus 5 square upon x plus 5 where x is not equal to minus 5. And fourth, fx is equal to mod of x minus 5. Okay. So first, fx is equal to x minus 5. This we want to check the continuity for every real number. Why? Because for every real number x, this function is defined. Okay. So let x equals to a, where a belongs to R. Okay. So if you want to check the continuity, then what are the three things you have to check? Left hand limit, right hand limit, and value of the function. If all the three are same, then we can say function is continuous. Or limit of the function and value of the function both are same, then also we can say that the function is continuous. Limit exists means left hand limit is equal to right hand limit. Okay. So first of all, I am finding value of the function. So f of a. So fx is x minus 5. So f of a will be a minus 5. Give it result number 1. Then you find out left hand limit. That is limit x tends to a minus fx. That is equal to limit x tends to a minus fx. Here fx is what? X minus 5. So apply the limit. What you get? In place of x I have to write a minus limit of constant is constant. So a minus 5, give it result number 2. Now you find out RHL, that is right hand limit. Limit x tends to a plus fx. Right hand limit means a plus. So that is equal to limit x tends to a plus fx. Again function is what? X minus 5. Function is not going to change. Now in place of x you write down a, limit applying minus 5. So from 1, 2 and 3 what you understood? From 1, 2 and 3, left hand limit is equal to right hand limit is equal to value of the function. Value of the function is f of x. So therefore function is continuous at x equals to a, where a belongs to R. Means function is continuous for every real number. Now coming to the second part. Fx is equal to 1 upon x minus 5 when x is not equal to 5. Why x is not equal to 5? Because denominator gets a 0. 1 upon 0 will be undefined. So that is the reason x should not be 5. If x is equal to 5, then function is not defined. Okay. So again, let x equals to a, where a belongs to what? R minus 5. We don't have to take 5. Okay, R minus 5. Now, we'll find out the value of the function f of a. That is what? 1 upon a minus 5. Because fx is 1 upon x minus 5. So f of a, in place of x we are writing a in left hand side. So in right hand side also in place of x we write a. Give it result number 1. Now you find out left hand limit. Limit x tends to a minus fx. That is equal to limit x tends to a minus. Function is not going to change. 1 upon x minus 5. Okay, apply the limit. Limit of fx upon j is limit of fx upon limit of j. Means limit of 1 is 1. Upon limit of x minus 5. Means limit of x when x tends to a is a minus limit of constant is constant. So give it as number 2. Now you find out RHL. That is right hand limit. Limit x tends to a plus fx. That is equal to limit x tends to a plus fx. What is here? Fx, same 1 upon x minus 5. 1 upon x minus 5. Apply the limit. Limit of fx upon j is limit of fx upon limit of j. So limit of 1 is 1 upon limit of j, that is limit of x minus limit of 5. So limit of x when x tends to a is a, limit of constant is constant. Give it 3. So same way from 1, 2 and 3, LHL is equal to RHL is equal to value of the function. Therefore function is continuous at x equals to a, where a belongs to R minus which number? 5. Except 5, for all real number this function is continuous. Now third. Okay, fx equal to x square minus 5 square upon x plus 5 and x is not equal to minus 5. Okay, so here first of all I assume that x equals to a, where a may be any real number but not minus 5. Now I'll find out f of a. So f of a will be a square minus 5 square upon a plus 5. In place of x I have written a. So numerator, what are the factors? A minus 5 into a plus 5 upon a plus 5. So a plus 5 will get cancelled. You are getting what? A minus 5. Give it result number 1. Now you find out RHL or LHL, whichever. RHL limit x tends to a plus fx. So here fx, okay, I'll write. That is equal to limit x tends to a plus fx is what? X square minus 5 square upon x plus 5. So that is equal to limit x tends to a plus, or directly you can apply the rule, limit x tends to x raised to n minus a raised to n is what, n into a raised to n minus 1. But here it is what, another number 5, so we cannot apply that rule. If it is a here, then we can apply that rule. Okay, so here I am doing the which one, factors of numerator, x minus 5 into x plus 5 upon what, x plus 5. So x plus 5 will get cancelled. So what you are getting, x minus 5, limit of x minus 5. So in place of x you write a, and in place of limit of constant is constant, so limit of 5 will be 5. So this is what a minus 5 gives us number 2. Now we'll find out LHL. Left hand limit x tends to a minus fx. So fx is what, x square minus 5 square upon x plus 5. Okay, now again apply the limit directly also you can say, or taking the which one, factors cancellation, and then apply the limit, then also it will do. So I am applying the limit, so a square minus 5 square upon a plus 5, because a is not equal to 0, so we can apply, sorry, a is not equal to minus 5, so here again you will get a minus 5 into a plus 5 upon what, a plus 5, so a plus 5 get cancelled, you are getting a minus 5. So again you observe this is 1, 2 and 3. From 1, 2 and 3 what you can say, from 1, 2 and 3, LHL is equal to RHL is equal to value of the function. What is the value of the function, f of a? So therefore function is continuous at x equals to a, where a may be any real number other than what, minus 5. Okay, now last one that is very important, fx to the mod of x minus 5. First of all we have to remove the modulus. So for removing the modulus, this I can write what, x minus 5 when x is greater than or equal to 5, and is equal to 5 minus x when x is less than 5. See, when x is greater than 5, this modulus will be what, plus of x minus 5. When x is less than 5, this modulus will become what, minus of x minus 5. So minus of x minus 5 will be minus x minus or minus plus 5, so 5 minus x. Okay, so we have to divide it into cases. Case 1 I am writing what, when x is greater than 5. Case 2 I am writing, or case 1 you can take x is greater than or equal to 5. Case 2, x is less than 5, or let us take x greater than 5. And case 3, x is equal to 5. Okay, for x greater than 5, I'll assume case 1, let x is equal to a. So here fx is equal to what, when x is greater than 5, when x is greater than 5, what is the function, x minus 5. Okay, now you find out f of a. So f of a will be what, a minus 5. Then you find out RHL, right hand limit, that will be what, limit x tends to a plus fx. Fx is what, x minus 5. So you will get what, a minus 5. Same way you take LHL, limit x tends to a minus. A minus, see, in mind you have to remember, suppose there it is 5, 4 and 6. So x is greater than 5. So I am assuming, I am thinking in my mind that x is 6, a is 6. So when a is 6, so 6 plus means 6.01. 6.01 definitely greater than 5. Okay, now x tends to a minus means 5.99. 5.99 is again greater than 5. So function is going to remain same, x minus 5. So what you will get, a minus 5. So give it result number 1, this is 2 and this is 3. From 1, 2 and 3 I can say limit this function is continuous for x greater than 5. Now case 2, for x less than 5, again function will be what here, when x is less than 5, you know what is the function, fx is equal to 5 minus x. Okay, so f of a, let x is equal to a, where a is less than 5. A is less than 5 means in mind you can assume that a is equal to 4. Okay, so f of a is equal to 5 minus a. Now you find out right hand limit. So right hand limit will be what, limit x tends to a plus. We have thought a what, 4 in my mind. So 4 plus means 4.1. 4.1 is what, less than 5. So function is same, 5 minus x. So what you will get, applying the limit 5 minus a. This is 1, this is 2. Now you take LHL, left hand limit. So limit x tends to a minus. A minus means 4 before 4. Before 4 means 3.99. So 3.99 is again less than 5. So less than by function is not going to change, 5 minus x. So again you apply the limit of constant, limit a. Limit x tends to a when x is equal to a is a. give it 3. So again from 1, 2 and 3 I can say function is continuous for x is less than 5. So when x is equal to a, when a is less than 5. Now case 3, for x is equal to 5. For x is equal to 5, case 3. So limit, here I will find out right hand limit. What is right hand limit? Limit x tends to 5 plus. You have to check for 5. X is equal to 5. Limit x tends to 5 plus. When x is greater than 5, what is the function? X minus 5. So 5 minus 5 will be how much? 0. Then you take left hand limit. Limit x tends to 5 minus. When x is less than 5, what is the function? 5 minus x. So what you are getting? 0. And you find out f of 5. So f of 5 you put mod of 5 minus 5. That is equal to how much? 0. So what you understood here, from 1, 2 and 3, left hand limit is equal to right hand limit is equal to value of the function, therefore function is continuous at x equals to 5. Thus in all the cases, case 1, case 2 and case 3, in all cases function is continuous, means function is continuous for all x belongs to R.